Hey everybody, welcome to the course. This video is part of several demonstration videos whose purpose is to explain how to best self-pace through the study of this course and how to best use the various resources provided to you to help you succeed in learning this course. I have provided several types of resources, including this video and a few other videos, and in this video I'm going to show the best process which I recommend in using primary learning materials for the course, the modules. Except for module 1, the majority of the modules come in the form of Jupyter Notebook, which is the Python programming environment that you will be using throughout the course. By using the same Jupyter Notebook that you'll be using, I will demonstrate ways that you can go through the examples and materials in the course, how to be an active learner, take notes, manage the different notebooks, and how to self-experiment with the exercises and examples provided in the resources. Now let's go. A few things on the front. In order for you to follow along, there are a few prerequisites that you have to do prior to starting this demonstration. You will need to have installed Python and set up the Python programming environment by following the tutorials in Module 1 and 2.0. That includes modules 1.1 through 1.4 and Module 2.0, which sets up the Rise slideshow. As you can see here, I have the module 1.1 through 1.4 and the module 2.0. After completing these modules as the prerequisites to follow along in this demonstration, you will also need to have downloaded the modules 2.1 and 2.2. These are the modules that I will be demonstrating on how to go through them and do the self-study. As you can see here, this is the file directory where I keep my Python learning materials for this course, and I suggest that you do the same. The ways that you can customize the Python work directory is included in Module 1, one of the tutorials. And of course, you can feel free to change the exact directory path in your Windows for the course and for the learning materials, but be sure to sync up that path with your work directory of your Jupyter Notebook. For this course, majority of the learning modules come in the format of the slideshow. That's a Rise slideshow that I was talking about previously. Although you do not have to turn on Rise slideshow when you go through the examples, I would recommend that you do so because it hides the following steps when you learn in the middle of the step, so that you can learn to better anticipate the outcome and better understand the languages. Because it's hard to take notes when you are in the slideshow mode, here's what I recommend. For each of the slideshow module, for instance, module 2.1, I have also made a copy of the same file, Jupyter Notebook, and give it a different name. For instance, it says notes, which clearly indicates to myself that I will include notes in this module. With the learning materials the same, but in addition, it will include my own notes. So when I prepare for the exam and do the homework, etc., I can further browse my notes and I can keep adding more notes to this Jupyter Notebook file. It's always a good idea to have a backup original copy of the learning material in here. Therefore, in this demonstration, I'm going to open the original Jupyter Notebook that I downloaded from Blackboard Canvas, and use it in slideshow mode, whereas I will also open my notes version to add notes and do experimentation with the codes. Let's get the hands-on started. Let's follow the routine procedure to launch Jupyter Notebook. The first thing you will do is go to the Windows Run window. I like to use the Windows key and the R key combination. R stands for Run, Windows Run the app, and I'm running the command prompt, CMD. And there you go. In the command prompt, I will enter Jupyter Notebook with Y, Jupyter, and I have my Jupyter Notebook window open. As you can see here, I have the original version of the modules in slideshow, and I have created copies of the same, which denotes the notes. For the first demonstration, I'm going to open up the module 2.1. I will use it as slideshow, so I will turn on slideshow. You can either click the button on the menu or use shortcut combination, which is Alt key and R. R stands for rise. As I said, I will also open up the notes. Since it's easier to switch between windows instead of tabs, I am going to single out the tab here in which I will put my notes. As I switch between the windows, it will become clear. One is the notes Jupyter Notebook, and the other is for slideshow in this main window. Alright, very well. Now this module 2.1 is about Python language basics. For those of you who had much experience with Python backgrounds, you probably can quickly browse through and skip a lot of the exercises here, because this part is mainly intended for Python beginners. And although the majority of this part is focused on some of the basic Python data elements, this is not in the core part of the Python for business analytics or data analytics. So these are mostly Python backbone basic elements. To navigate through the slideshow, the best way is to use the space key so that you will not skip some of the sub-slides. Be careful to read through the messages that I leave, because every message here is important. Language semantics of the Python programming. Before you can use any of the packages, you will need to import them, which will become very clear and a routine part of your activities and learning exercises for the homework, for the in-class hackshops, etc. So best way to import pandas would be to use the import keyword, and then as you can name an alias to quickly use that instead of typing pandas every time afterwards. Now, so at this moment, I would suggest that you can go to your notes, Jupyter Notebook, do some exercises here. So remember, when you open up a Jupyter Notebook, you will need to run from the very beginning of the code cell type. I'm talking about the code cell type that includes the Python codes in order for it to take effect. Even though the Jupyter Notebook file that you saved and you opened saved the outputs and the status of the previously run cells, it's showing that it has been run previously, but because you have just opened up a new Jupyter Notebook session here, all the previously run cells, including the objects that are saved in the memories, are gone. So you would have to rerun that again for that to take effect. For instance, you need to import pandas here before you can use pandas in the below. Otherwise, it is going to report errors. So I'm going to run this, and now it has been run, and then you can use pandas. Pay less attention to the specific pandas version here, as your version might be different as you install newer versions of pandas or upgrade the pandas package. Alright, that's good. And let's keep going. Here's one important point. As you start learning Python as a beginner, you will tend to experience a lot of error messages. Now, error messages are because of different kinds of mistakes when you write your programs. And these are because of the fact that Python programming language is a strongly typed language, is case sensitive, and involves a lot of complexities and intricacies, even though I would say the language is still very intuitive and reads like English. But still, you have to follow the grammatical rules and principles of Python language programming. And that is actually a big part of your learning experience here. So as you progress through the course and go from a beginner Python learner to be an intermediate Python learner, the goal here is actually not trying to reduce the number of coding errors and the number of error messages that you get when you do your activities in Python programming. Let me repeat, the goal is not to reduce the number of error messages that you get. That is actually a misleading point. Now, oftentimes, beginners of Python dreams about making 0 mistakes when they program. However, that's a misconception. I make mistakes. Many of the error messages that I get now still are very similar to the early stages of my Python learning. Why is that? That is because writing programming languages are similar to writing articles. When you write an article, sometimes you have misspelling. The reason is not because you are becoming less familiar with the words and language, but because of you are becoming more productive and you are trying to convey and come up with more complex solutions. When there is more complexity, you are bound to make mistakes. But rest assured, your improvement in productivity and efficiency is not reflected in the number of error messages that you get. But however, it is reflected in the level of efficiency in your debugging those error messages. So don't be afraid of the error messages. However, be afraid of your lack of improvement in your efficacy in debugging those error messages, in understanding and improving your anticipation of error messages. Let me tell you, it's actually a relief when you see an error message and see how familiar that is, and you immediately know what might be going on and what might be wrong, and it probably only takes 10 seconds or less than a minute to correct a bug in a key part of the program. That is actually a relief. So over time, as you go more advanced, pay attention to your improved skill set and familiarity and productivity in debugging your errors in your codes. Let's keep going. As I was talking about error messages, let's see what kind of error messages you might get in importing the packages at the very beginning of your learning Python. This person is trying to import a package named Tiger. She gets an error message, module not found error, no module named Tiger. There can be several scenarios here. First of all, examine the codes and make sure that the keyword of the command here, the import command, is spelled correctly. It is. There's a space in between. The number of spaces here do not really matter, but for elegancy of the codes, it's best to keep only one space here. And then the package name, Tiger. Now, the several scenarios are, for one, Tiger might be an actual package name. However, importing it is unsuccessful because it has not been installed. The second scenario is that Tiger is not really a package that exists, and you are not supposed to import it. A third scenario that lies in between is that package whose name is similar to Tiger, maybe Tiger with a K. However, you misspell the name of the package wrong as Tiger. Therefore, the same error message will appear. Carefully think about the different scenarios and identify the root cause of this error message and then correct it. Alright, as in another example here, this person is trying to import pandas. It reads OK, import pandas as PD. The exact alias that you give this imported package does not matter as long as it's all letters and there's no space in it. I think it can have underscore, but it cannot have dash because dash is interpreted in Python as minus calculation. However, upon getting the same error message, you will examine whether or not it's a keyword command misspelling or it's the package's misspelling. Now, pandas spells good when you read it. However, when you examine the cases here, it's actually not correct. Pandas packages, as well as the vast majority of the packages, when you import them in Python, they should be lower cases. The vast majority of the packages are imported in lower cases. This is the way they are installed in Windows. Therefore, you should replace the capital letter P with the lowercase p, and then that should do it. As with, if I were to go back, you will see that it is lowercase here, and it worked. Alright. Now, at this moment, it will be interesting to experiment with a few things. For instance, I'm going to make a few notes, code cells here, and I'll denote my notes. So what I would like to show here is how to self-experiment with the codes and with what you have learned here to, kind of explore a little bit more, to go beyond what is demonstrated. And doing this is extremely helpful, especially for beginner learners, to kind of understand the territories and understand the boundaries of what's good and what's not good, the do's and don'ts of the Python programming. So if I were to have a typo here, either capital letter import, which you can clearly see the difference. If it's capital letter, it's misspelled. Python is case sensitive. Always remember that. In lower cases, it's all good. So if it's import, but if I accidentally included a capital R, you can see that the color scheme is different. So the color-coded keywords is also another helpful cues here. If I do import, and other than pandas, we also have the NumPy. If I import NumPy here, NumPy is not color-coded, even if I change it to lowercase, because the object names are not color-coded. Only the command keywords are color-coded. The command keywords as well as the language keywords. But again, if I were to import NumPy as this, sometimes you see NumPy spelled like that because that is the name, the style of the name that people refer to as a NumPy package. The capital Pi is meant to mimic the Python beginning letters, initials. However, that is not the correct spelling of the package installed on your Windows system. So if I do this, it's not going to work. The same kind of message here appears, no module named NumPy. And if I correct that into this, initial letter lower, but the P remains as capital, it won't still work. But if I correct everything to be lower cases, now it will work. After it works, I can use NumPy to examine the version here. But you may wonder, and it is a good question, you may wonder if you can use NumPy even though I had imported NumPy as alias NP. It's a good question. Let's find out. It's actually not working because I did not import NumPy and keep its name. However, if you prefer to use NumPy and use NP at the same time, this is something that you can do. You can import NumPy 2 different times, once as NP, the other as NumPy. And with that, you can make it work at both times. So let me demonstrate that you can run both at the same time, nothing breaks, although it only shows the output of the second line because the output of the first line is overwritten by this. Now, in order to show both, what you can do is include a print statement at the first line. You don't have to include a print statement for a second line because the output of the second line is automatically shown as the standing output. If you do that, you're going to see 2 kind of outputs here. The first output is a printed version of the value, which is a string. The second line is the output, which is a string value and contains the format of the string. That's why you see different formats, but the values are all the same. Another way to see that is to remove this, and in this case I can replace that semicolon, which in that case is the end of line, with a comma, which is kind of putting 2 things, the 2 outputs, 2 variables as part of the tuple, which you will learn tuple next part of the tutorial here. When you print these 2 variables as a tuple, now you will see 2 outputs. They look exactly the same as they are exactly the same. NumPy and NP are the same. NP is just an alias of NumPy. Great, so that is the experimentation and self-exploration that I encourage you to do. I encourage you to be an active learner. You actively explore the territories and the boundaries of Python programming as you go through the learning materials. Now let's keep going. The next part of the module talks about objects, methods, and attributes in Python. One of the most interesting objects in Python is string. String means letters. It doesn't have to be letters, it can be numbers and parentheses and punctuations, but this type of object is string. We store them as literal strings. And as a side, I like these superheroes such as Superman and Spider-Man, so I use them to make examples and exercises, questions, so I hope you also like them. Now, every string is an object instance, so they inherit the string type from the generic string objects, so they come with their own methods, such as for strings you can turn the letters into uppercases and lowercases. You can count the number of instances in a string. The entire word here within the quotes is a string object. You can see that you can enact method turning into uppercase on the literal string itself, or you can also assign that to an a variable a which holds the Superman string literal, and then enact the same method turning to uppercases on that variable which enacts the same method on the literal string. Isn't it fun? If you set up your systems correctly, you are able to be reminded about the available methods and attributes of each of the object instance. Not only a string, but also can be a function, can be other objects, and data frames and series that we will deal with a lot in later part of the semester. So let me demonstrate this part here in my notes. So earlier I imported NumPy. Now because I imported NumPy as a package, it has a lot of functions here and other objects and resources. So the utility here is after typing dot, you are ready to use the rich resources of NumPy package. But you can be reminded about what are available sometimes when the concepts become loose. After including the dot, you can click tab, and it can show you a list of things that you can do here. Now, it's not like you can randomly pick them and use. That's not the purpose. The purpose is that you know roughly what you're going to use, but cannot remember exactly the name, because Python requires strict typing and case sensitivity, so you need to get the spelling correct. This tab completion tool is here to help you tighten the loose ends. Alright, so that's the point. For instance, NumPy has a random package, random tool. Again, I can do ran, R-A-N, and when I hit tab, if random is the only unique tool within NumPy package, it's going to autocomplete. Or if I do RA, it's not unique. So it will show a list of tools and resources that begins with RN, and random is just one of them. I can select that, and random, this is an actual utility that generates random numbers. Alright, sounds good. Now keep going with the demonstration. The module then talks about functions, and a function is different from a method, where the methods is enacted on a specific object instance, such as the literals, and a variable that is a literal string. With the dot method, you can include the actual method and enact something on the instance of the object itself. In comparison, a function is a standalone function that does something by taking parameters. It's not enacted on itself, but a function is used to manage and manipulate something else or somethings else. Here, this specific function is used to test whether or not an object instance is of a particular object type. So you give the function two things. Order matters. The first thing that you give to the function is the object instance, and the second thing you give to the function is the object type that you are checking against the object instance here. For instance, here is the use case scenario for this function, is instance. It checks whether this literal string, Superman, is a string type. And obviously the answer will be true. It checks whether this variable a, which stores the literal string Superman, whether or not it is a float object type. Obviously the answer is no. So let me go to the same place here and take my own notes here. So sometimes I forget to include indications of my notes, so I will put it back. And here, sometimes you see again, I use tab completion a lot, particularly on those long, very unique functions. For instance, after typing is insta, it's quite likely that isInstance is the only function in Python. So I hit tab and it auto completes. I'm going to test if it will work if I switch around the two things. String Superman. If I switch around the two variables that I provide to the function, it is not going to work. It requires the specific order of the inputs here to the function, so be careful. Also, a lot of times you'll experience this error. Now, since this line involves no errors, I can run the same thing again, but I get an error. It says name A is not defined. How could that be? A is clearly defined here. Now the thing is, I have not defined A here. Why not? A is defined here. The thing is, when I was browsing the slideshow here, A is defined here, but A is only defined on paper. It's not defined in my Drupal Notebook session. How do I mean by that? I haven't run this line of code. I have to run the codes, especially for those new objects here. A is a new object instance. I have to run this before I can use that in this particular session. Now that I have run it, and if I close this Drupal Notebook and open again, I have to rerun again. This is the way that things work. Before using a new object in a new Python Drupal Notebook session here in the browser, you would have to run that and define it before you can use it. Now that I have already run this line of code that defines A as a literal string, then I can run this line of code that doesn't involve error. There you go. A is not a float type, A is a literal string. So it's false. But if I were to check instance of A as a literal string, I will get a true response. Great, things work. So now you have seen different kinds of errors here. Let's go through some of these. Now the first error, no module named Tiger. The cause of this error is that there is no Tiger package installed on this computer. And it's also very likely that Tiger is not an actual package, although you might be surprised. In the open source programming environment, people make their own packages and share with other programmers. There might be a Tiger package, but that I just didn't know. But for our purposes, we probably wouldn't ever use a Tiger package here. This error is the same type of error, but the cause of the error is different. Pandas is spelled incorrectly in terms of the initial letter of pandas. It should be all lowercase. And no errors here, but later I had some error here. This error of isInstance, the message tells you that the argument, the second argument, must be a type or a list of, or a tuple of types. So you can actually include, by reading this error message, you actually get some ideas. The second argument, now we know that there will be an error right? We expect an error here because I switched around the two inputs, the two variables provided to is instance. The function expects two arguments in the order of the instance and the object type. The instance doesn't seem to be a problem here, as you might also provide a object type as an instance and check the type of that object type. But the second instance have to be a limited range of different type of objects, and it must be a type. So you know how to fix this by switching around the inputs. But the point I'm making here is that by reading the error messages, actually you kind of get some new ideas for experimentation. You can actually include a list or a tuple of types to check whether or not an object instance is something but not something else. And let me demonstrate what I mean by that. Is instance, if I check the variable a, which we know it's Superman, literal string, but here I can include a list or, which is in the square bracket format, or a tuple, which is in a pair of parentheses. I can include a list of things. For instance, I check string, which should return true. I also check integer. I also check float. One line of code and find out the answer. And let's try that. So what we learned here is that by including a tuple of different object types, we are checking whether or not object instance A is of any of the object types that you provided. If it's any of that, it will return true. If it's nothing out of the list of alternative types, it will return false. So that is a neat feature of the function is instance here. Alright, so the module keeps going with the differences between assignment and comparison commands. So follow along with the use cases and scenarios and do your own exploration and experimentation. Alright, that is demonstration that I wanted to do. I like to show you the process that I recommend you going through the learning modules and doing your own experimentation and how to be an active learner. And next I'm going to open up the module 2.2 and do a little bit more demonstration in the similar vein. But know that as you progress into later parts of the modules, the content becomes more and more complex and actually more fun. Now here I have opened up module 2.2 as with my usual setup. I will turn on Rise slideshow here, and on the side I have the notes version of the same module where I will include my notes and do experimentation here. Module 2.2 is about the Python built-in data structures. These are the backbone of the more advanced data frames and data objects for analytics that we will use. But the backbone of those data types are built on these data objects and structures. So you want to learn these basics very well. Now, read the new notes here every time that you see them for the first time. Right, so the this module mostly are about these object types. A tuple, which means a list of things in parentheses. List is similar to tuple but not exactly the same. List is changeable, tuple is not. A list is included in a pair of square brackets. Dictionary is fun. It's hard to explain verbally, but it's better to go through the use cases here. And set is a unique bundle of objects or instances. And keep going with the learning modules. Tuple versus list. As you go through the examples, you'll find out that tuple is non-changeable or immutable versus a list. A list can be changed. And as you go through the examples, you can try different things. For instance, here, when you have a tuple, if a tup A, which has three superheroes here, and by using index notation, try to index position 2, which is the third element, 0, 1, 2, Wonder Woman, try to replace Wonder Woman with Spider-Man, and Wonder Woman says no. Wonder Woman wouldn't want to be replaced. I'm kidding, actually. It's not that Wonder Woman wouldn't like to be replaced, but it's because the tuple is non-changeable. You cannot swap out and change the element of a tuple after a tuple is created, after a tuple instance is created. You want to create the tuple exactly as you intended it to be without being able to be changed. Meanwhile, you can actually change elements of a list if it's a list. However, for tuple, it cannot be changed. Let me remind you that you will need to run the codes that define the objects before you can run the codes that use them. For instance, if I run this line without running the line of codes above it, I'm going to get a different type of error. Here, the correct error that you are supposed to get is saying that tuple cannot be changed. The elements of tuple cannot be assigned or replaced. However, if I run this, it's going to tell me before running into the actual error, it's going to run into a different error, a more surface level error, which is saying that tup A is not defined. Tup A is non-existent, and how can you change it, right? And this indicates that you probably haven't run the codes that define tuple A in the first place. So you need to do that. Run the codes above it, and get to see the contents of the tuple. And then when you run this line, the actual error is going to show up here. It says tuple object does not support item assignment, which is essentially saying that the elements of a tuple cannot be changed. Tuples are immutable. Tuples are fixed length. You cannot add in a new element. You cannot enlarge a tuple, but you can do that with lists. So when you go to lists, things become more fun. Another of my suggestions are that even with the simple examples, when it looks simple, it's also a good exercise. It's a good idea to simply retype the same codes or change a few things if you want, instead of simply running the codes. So if I run this, tuple A, add tuple A with another tuple, the other tuple includes tuple B in it and plus one more element. So you will expect one layer of parentheses, one tuple included in a tuple, and then add the surface level tuple together, so you have two layers. If the tuple outside, for which one of the element is itself a tuple. The exercise I'm talking about is try to recreate the code by typing instead of copy paste. When you type, you'll discover new things. For instance, when you type, and if you make this kind of mistake, you're going to run into error. Tup A is not defined, and then it is the process of going through and experiencing many error messages, and that you try to debug the errors, that you improve your Python programming. So if I try to debug the error but accidentally type in both tup A, I'm going to get something different from that, and you'll wonder what happened. And upon closer examination, you'll find that some of the spellings are mistaken. So in manual typing, you'll discover a lot more hidden things in Python programming that you can learn from. Eventually, the idea is to expose yourself to different scenarios and different territories and use cases of even using the same tools, and over time you'll greatly enhance your familiarity with different error messages so that you are better and more efficiently able to debug the codes in order to try to do the tasks that you are trying to do. And now you can come back to the slideshow and continue the learning and exploration. Alright, so this is the demonstration I like to show. A few final words. The majority of the learning materials are provided as slideshows. Of course, those are adapted from the textbook, so use the textbook for expanded reading and exposure to similar scenarios in the book. The book goes into a great length to use different examples. The modules have limited space, but start from the module and the slideshow. The process in this demonstration video is the process that I encourage everybody to learn the materials. Read and carefully study the slides. Take your notes if needed. Do your experimentation on a copy of the module in Jupyter Notebook and try different things. And above all, and most importantly, have fun. Python is really fun. I hope this video is useful, and see you later.